In the previous section, we had an introduction to DevOps. We understood what DevOps is, why it is important, and we even took a look at what is it that by the end of the course we will be able to do. But before being able to do all that, we have to start with the basics, Git and the branch structure. So during this lecture, I want to help you understand what source control is, in case you don't yet know what it is, and the ideal branch structure that you should have inside of your repositories to enable good CI and CD. So let's talk about what is version control, or revision control, or source control, as it is also known as. And it basically is the management of changes made to documents. It isn't limited to tracking changes or versions, but can contain a bunch of information about who made those changes, often called the blame, perhaps so we can blame bugs into someone. And these may also contain information about when was the change made and what were the actual changes, down to each and every single one of the lines in a particular document. Why is version control so important? Well, let me explain it to you in a little bit of a short story. When I think back to when I was in school, I remember that we were constantly creating quote-unquote new versions of a single document. We perhaps had the final project, and then we created the final project, and then we had final project 2, and so on. And of course, now I know better, but in this scenario, Google Docs is particularly helpful. But back then, this precarious form of version control allowed me to go back to older versions if I made some terrible mistakes. Sometimes it allowed me to compare how much I had worked that week from one version to another, and often it would also allow me to merge the work of my teammates in a new version. All of these are valid reasons for why version control is important. Keeping track of your changes, the ability to go back to a previous working version, and easily adding someone else's work. And all of these, of course, being tracked in different versions. Of course, I am not saying that that is exactly what you should do, having and creating manually new versions of your documents, but it is all going to be done by, in our scenario, Git. So these three things. This is what it is important: keeping track of changes, the ability to go back to a previous working version, and easily add someone else's work. These three things are the ones that you should keep in mind when you ask yourself why you should use version control. Now, hopefully, since you are interested in CI and CD, you already knew this. But in case you don't, let's also talk about where you can use Git version control, and the answer is pretty much everywhere. You can use it with code, with JavaScript, CSS, C#, XAML, Objective-C, Java, whatever code file that you can imagine, but you could also use it with pretty much everything else, like a Word document or a PDF document. There really is no limit to what you can track with Git. Pretty much any type of file that you can imagine, you can track the changes made on that file through Git. Now, how do development teams use version control? Well, this is actually quite interesting, and usually you are going to have a computer where you create a project, and there you initialize the version control that you have chosen. In our case, it is going to be Git. But because we're going to be working with themes, this same repository with all of the changes that have ever been made can be shared with a second computer, maybe the computer of your teammate. And now that person can make their own changes and commit them to the same repository and share them with you. And this sharing most of the time is going to be happening through a third computer, which is more often than not going to be in the cloud. In fact, in our case, this third computer is going to be GitHub, hosting in the cloud that same repository, so that eventually anyone can connect to this cloud computer, a repository in our case inside of GitHub, and collaborate inside of the same repository. This is the ideal scenario. This is why you use version control. Let's now talk about how, once you have version control, you should conform your branches. And this is where things start to get a little bit more interesting, especially if you already knew what version control was. And the reason why a good branch structure is so important is because it is going to enable you to always have a working version of your project, which is very important. It shouldn't matter if you have just implemented a new feature and it may have broken some things, because you always somewhere have a working version of your project for any reason to deploy to your users, to go back to that working version so you can continue working from there, and so on. So let's talk about how is it that you're supposed to add new code if you should always have a new working version. Well, essentially you're going to have a master branch. This is created, and you may have seen it by default when you initialize a Git repository. And this master branch is where you should always have that working version. You rarely make direct commits into this master branch. Instead, what you do is have a test branch, and it is from this one from which you can send commits to the master, but only after you have tested that new version. So here you are already entirely sure that this version is working, then it is sent to master. And in fact, even before the test branch, you have the dev branch, where you make most of the direct commits. You create a new feature, you add it inside of the dev branch. And eventually, once it is ready for it to be tested, you send it to the test branch. The test team is going to be using this version that is inside of the test branch, test it, and once they are sure that it works, send it to master. This is the main structure of your branches, the ideal main structure of your branches. Now let's take a closer look at that dev branch, where most of the interesting things are going to happen, where you are going to be adding your features. It may not be the case that you add those features directly to the dev branch, but you may also create branches that eventually merge into the dev branch. For example, feature 1 and feature 2, each of which contain their own commits, and only when they are ready are they merged into the dev branch. And the same goes for branches that solve a particular bug, bug 1, bug 2, and so on. These can also in some scenarios happen inside of the test branch, although this is less common, where you've already merged from the dev branch to the test branch and just quickly solve a bug or add a feature in here. But again, this is less common. The thing that is going to be more common is that you merge directly from the dev branch into the test branch. Once you have added some feature to the dev branch and it is ready for it to be tested. So eventually, this is what you end up with: a master branch that always has a working version of your project, a test branch that receives code that is ready to be tested and sends it over to master only when it has already been fully tested, it is entirely ready, and it works very well. Before that, you have a dev branch where you create and add the new features, and from which you merge into the test branch for the test team to make whatever tests they need. This is the main structure that you should keep in mind, and the one that ideally all of your projects are going to have. So now that you know what source control is and what branch structure your project should have, in the next lecture we're going to dive right in. We're going to create a test project, initialize a repository, stage and commit some changes so we can work through the process of having precisely this structure and talking about how this is going to be related to GitHub, which I've already mentioned is going to be the foundation of the entire CI/CD process.